Okay, let's have a look at the derivative of a function and its applications. So one of the most common application is that we can find the slope of the tangent for any given value of x. So let's say we're looking at this function, x squared plus 3x minus 4, and we would like to use the x value 2. Then we find the derivative dy dx, which basically means find the derivative of the function y with respect to x, since x is our variable. Then we find this expression 2x plus 3, because remember we move down the exponent in front, so 2 times x, and then decrease it by 1. So it will be to the power of 1, and we don't write out because it doesn't change the expression, so we just write 2x. And then 3x, the derivative of 3x is going to be 3, and the derivative of any number, any constant, positive, negative, no matter how small, how big it is, it's going to be 0, so nothing here. So this is the derivative of this function. Now let's substitute x is equal to 2 into the function. So this means 2 times x, or 2 times 2, and then we add 3, we get 7. This means that if we look at the function x squared plus 3x minus 4, where x is 2, just go to 2 here from the x-axis, go up here, 2, 3, 4, 5, y is going to be 6. Here, if you try to draw a tangent to the curve of the function, it's going to be very steep like this, going uphill. So the slope is going to be 7. Okay, that's the slope of this tangent at this point where x is equal to 2. That's basically what it means. So let's have a look at another example. Find the slope of the tangent to the function y is equal to minus 2x2 plus x plus 5, where x is equal to minus 1. First we find the derivative of the function, so dy dx is equal to, move down the 2 in front, so it becomes 2 times this minus 2 that is already there, which becomes minus 4, and then x, decrease the exponent by 1, so it's just to the power of 1. We don't write it out. And it really says plus 1 times x here, so it's going to be, the derivative of x is going to be 1, just 1. And then the constant plus 5 disappears. So this is the derivative of the function. Now substitute minus 1 for x, and we get minus 4 times x, or minus 4 times the value for x, minus 1, and then plus 1. So we get the value 5. This means that where this function, where the x value is minus 1, if we draw a tangent to the curve of that function, the slope is going to be 5. And this is the algebraic way to do it. Let's have a look at some more examples. So let's see if we can do this. I'm just going to move this down a little bit. So y is equal to 3x squared minus x plus 2. Now let's find the derivative first. Dy dx, dx is equal to, take the exponent, move it in front, so 2 times 3 times x to the power of 1, but I'm not going to write it out. And then it says really minus 1 times x here, so we're just going to be left with minus 1, and the constant plus 2 disappears. Let's clean it up a little bit. So 2 times 3 is 6, 6x minus 1. So for x is equal to 3, that gives us this value. Let's see, this is the derivative of the function, so we just substitute 3 for x and we get 6 times, we can write it like this, bracket 3 and then minus 1. So 18 minus 1 is equal to 17. So let's have a look at this calculator. Just to check, I'm going to open up a graphs page and then 3x2 minus x plus 2. 3 times x squared minus x plus 2. Minus x plus 2. This is how it looks like. And then maybe we can zoom out a little bit. Zoom out, number 4, zoom out, and then we can draw another zoom and just use the box zoom. We click up here for the first corner, then draw a box and then the second corner, because this is the most interesting part. Click escape to go out of the zoom mode, and then I can grab this and move it somewhere here. So what was the question again? Where x is equal to 3. So let's go back. Here we go, x is equal to 3. I'm just going to do like this. I'm going to go to geometry, points and lines, and then point on the curve. I'm just going to click on the graph and then click somewhere. And then we got 1.5. That's not what we wanted. We wanted x is equal to 3. So I think we're going to have to zoom out a little bit. Let's do that. Zoom out here and let's go escape. Now I'm going to click and click again, and then I can click delete and type the value that I want. I want 3 for x, and then press enter. Now I see that the y value is going to be 26. So if you can imagine a tangent, I'm actually going to zoom out one more time. Zoom out around here. So if you can imagine a tangent to the curve going through that point, it's going to be very steep uphill, almost vertical line. So let's see if we can, if we can find the slope. Well, I'm going to show you two different ways of doing it. First, we can open up a graphs page. We can just have a look at the function f1 of x. This is the function. So how about we find the derivative dx. It doesn't say dy dx, but it says d derivative and then of the whole expression dx. So the name of our function in the calculator is f1 of x. And there we go, 6x minus 1. You remember, 6x minus 1. Now we can also use this function, derivative at a point. So variable x, and for x is equal to 3, and the first derivative, that's the only one we know so far. So the derivative of this function f1 of x with respect to x, where x is equal to 3, and then we get 17. So this tells us that the slope is 17. The slope of the tangent is going to be 17. Now let's check this with another way of doing it. Geometry, points and lines, and tangent. I think you've seen this in a previous tutorial. And then I just click on that point, and then we get the equation of the tangent, not just the slope. We get the whole equation of the tangent. I can grab this and extend these arrows a little bit. There we see the tangent. And as you remember, the coefficient in front of x here tells us the slope. So the slope is 17. This number, this constant minus 25, tells us where the tangent is going to cross the y-axis. If we keep it standard here, we're going to see that it crosses where y is equal to minus 25. But the exercise just was to find the slope of the tangent. Now we know two ways of doing it with a calculator, either like this, or finding the equation and then look at this number, or do it with algebra. Let's do one more, and then you can try number 3 and number 4 on your own. Find the slope of the tangent to the function where x is minus 4. Okay, let's get some more space and write down the function. Y is equal to minus x squared minus 4x plus 1. So first we would like to find out what the derivative of this function is. Dy dx is equal to, the 2 goes in front, it really says minus 1 times x2 here, but we don't write it out. So it's 2 times minus 1, we do it right away, minus 2x, and then to the power of 1. It's not necessary to write it out, so we're just going to leave it like that, and then derivative minus 4x is minus 4, and this is going to be nothing. So for x is equal to minus 4, we just substitute minus 4 for x here. This will give us minus 2, and then I'm going to write bracket minus 4, and then minus 4. This is minus 2 times minus 4 is equal to 8 minus 4 is equal to 4. Okay, let's check if this is a reasonable. Minus x2 minus 4x plus 1, that's the function. And then derivative minus 2x minus 4, we substitute minus 4 into this, so minus 2 times minus 4 is 8, and then minus 4. Okay, it looks okay. Let's create a new document and check if we're right. I'm going to draw the graph right away. Minus x2, remember to use this minus sign, minus x2 minus 4x plus 1. There we go. And since we have a negative x2 term, it's going to be a maximum. It's going to be like a hill like this. So the top of the hill is going to be the maximum point. X is equal to minus 4, minus 3 or 4. So if we go up here from minus 4, it's going to be here somewhere. So it's going to be positive value for sure. Let's do it this way with geometry, points and lines, and then point on, and the graph. I'm gonna fail just so I show you how to fix it in case you can't get the value you want the first time. We wanted x is equal to minus 4. Remember to sometimes click escape to go out of that mode. Then I'm just going to click and click again, delete, minus with this minus sign, minus 4, and that's the point. Now I'm gonna use geometry again and points and lines and draw the tangent. Click on the point and there we go. And I can click escape to go out of this tangent drawing mode, and then I can move this equation. And if I look at the coefficient in front of x, it's 4. and our value for the slope was also 4, so it's all correct.